Okay, and here we are. Yeah, I just gave the kids 3 seconds and they're already finished with this do now. All right, so let's get this going. So they define where a function was increasing, decreasing. You go to your first derivative. All right, first of all, did you guys get the right first derivative? If you didn't get that, you are in so much trouble. All right. Now, you want to make a sign chart for the first derivative. You got the first derivative. How do you know where it can change signs? Critical values, right? Where it's 0 undefined, but this is always defined. So you had to set this equal to 0. How many critical values did you get? 3 of them? Let's see if you're right. So when you set this equal to 0, you got a factor to do that. Now, whoa. I'll just take this one. No, well, I don't want to do all that. It's too much, too much. When you factor, first you pull out the 5x squared. And guys, if you're looking at your work and you pulled out the 5x squared and then you see you have to factor the x squared plus 4x plus 3, don't forget to keep bringing down the 5x squared. That's part of your first derivative. Okay, that's also a factor. Don't leave them behind. So yeah, the first derivative is 5x squared times x plus 3 times x plus 1. And it's equal to 0 when x is 0, -3, and -1. Do we all get those critical values? Yeah, nice. Now, this factor, the x, is squared. What is that foreshadowing? It's going to bounce, so there'll be no sign change at 0. And lo and behold, when you make your sign chart, you mark it off at -3, -1, and 0. That's it. You take your test values. Now, when you take your test values, I know you guys love the calculator and like to punch it in. Some people are plugging into the original value of the original first derivative, but plug it into the factor form. Look how easy it is because 5x squared is always positive, right? We don't have to worry about where it's 0 because we already marked that. That's not going to be in one of the intervals. So you don't have to worry about the 5x squared. You just take numbers and plug them into these two factors and see if the product's positive or negative. Saves you time. So does anyone need help, like seeing, like I chose like f of 1 to find out over here. It doesn't matter. You pick a number greater than 0, 1, that factor's positive, that's positive, so the product's positive. A number between -1 and 0, I chose -0.5. Chose whatever you wanted to. But both, again, would be positive. So the product's positive. And a number between, yeah, you got that idea, right? Yeah, I don't want to bore you with that. Okay, so now you know where the first derivative is positive and where it's negative. So when you're asked where is it decreasing, what are you looking for? Where it's negative, right? So from -3 to 0. And then where is it increasing? Should be from -infinity to -3, from -1 to 0, and then 0 to infinity. But you can just put all that together if you want. You can say from -1 to infinity. See, at 0, the derivative is not positive. It's 0. So technically, that's called a stationary point. It's not going up. It's not going down. It's just, yeah. So if you don't want to include it, you don't have to. If you want to, you can. You're not going to get penalized either way. Anyone get that right? Woo-hoo. Okay. If you got it wrong, you know where you went wrong? Okay, cool. All right, let's talk about that homework. That was fun. All right, so check out your answers. I'm going to pause this because it's boring. Okay, we're back. What are we going over, kids? Yes, 6. Excellent choice. Excellent choice. Nice. I still think it was an excellent choice. Was this the one you guys got right?
No.
Okay. If it's bleeding, you want to do a nerve?
And this calc is not that good. Just a little bit.
People would rather just bleed to death and stay in calc than go to a nurse. No, I think, yeah. Yeah, I don't blame you. All right, so they give you a graph of the derivative, and they say what's true about the function. Oh, I like this question. This is kind of tough. Okay, so when the derivative is below the x-axis, when it's negative, what's the function doing? Decreasing, right? So it's decreasing all the way till you get to 1. And then after 1, you see how the derivative is positive? So it's increasing. Now, I don't know where it's decreasing to. I just know it's going to look like this. It's going to get to 1, wherever it is, and then go back up again. Oops. Well, it's good enough. Let me just move that over. Okay. It's not going to be exactly like that, but I know it's decreasing, so it gets to 1, then it's increasing. Now I can answer the questions. Is f of 0 going to be less than f of 1? Would f of 0 be less than f of 1? No way. Get that out of there. Would f of 1 be greater than f of 2? Nope. Is f of 2 greater than f of 3? Is this y greater than that y? Is f of 0 greater than f of 1? Ah, yeah. Circle it with that pen there. Yeah, I know. Oh, that's what's confusing. Yeah, my answer choices are different, but my answer is still going to be the right answer, just in the different order, different version here.
But then our answer is
No, it just...
go back. So you had first.
Yeah, the copy that I have to project is not the one that goes, it's not yours, but the answer key goes with yours. So the concept's all the same, so the choices are in different order. So whatever one says f of 0 is greater than f of 1. I didn't think calculus was hard enough. I had to make it a little... All right, what else we got, guys? Yes? 3. 3 is a good one? All right, they like this. They like your choice this time. All right. So we got to get the derivative. They ask us if a function's increasing, decreasing, right to the first derivative. What do we need to get the first derivative? Lodi high. All right, Lodi high is going to equal what? No, I want to know what Lodi high is going to equal. What is the denominator times the numerator going to equal? 0. Okay. Lodi high less high d low. What's d low? Negative 2x all over the denominator squared. So the first derivative can be cleaned up. So it's 2x over 1 minus x squared squared. Hey, can I distribute exponents? Even with that, like, my whole acting, you still agreed with me? I tried to give you, like, no, you can't distribute an exponent. You can only distribute multiplication over addition or subtraction, never exponent. So leave it. All right, so here's the first derivative. If you want to get your critical points, oh no, my first derivative is a fraction. Yeah, you're going to set the denominator equal to 0 to see when it's undefined, and the numerator equal to 0 to see when it's 0. So to get your critical values, we're going to set the numerator equal to 0, because that's when the derivative is 0. And what do we get? To 0. We set the denominator equal to 0 to see when it's undefined. And what do we get for that? Plus or minus 1. Thank you. So we have 3 critical values, right? And I'm just going to put the sign chart right there. Like that. So here's our sign chart. We're marking it off at -1, 0, 1. Whoa. Okay, well, the great thing about plugging in test values, what's the sign of the denominator going to be? No matter what number I plug in, it's going to be positive. So I just got to look for the sign of the numerator. Hey, when's that numerator going to be positive? When x is greater than 0. All right, let's do them all separately. Fine. No, you said erase that, please. All right. No, if you see, you've got something squared, right? You don't have to worry that it's going to be 0, because that's a critical value. You're not going to be picking that. That won't be in one of the intervals. So anything squared is positive. You're just looking for the sign. So I don't have to worry every single time about the denominator. It's always going to be positive. Next time, make it go there. Next time. So you take a number greater than 1, you already know the denominator is positive. Don't even worry about it. Like 6. Okay, sure, that's a good one. Okay, 2 times 6. Positive. We already know that's positive. Positive over positive is positive. Take a number between 0 and 1. 1/2. 2 times 1/2. Positive. We already know that's positive, right? Take a number like negative a half. Negative on top, and what do we know the denominator? Positive, negative over positive. And then a number less than negative 1. Negative 9. I like to throw you a bone every once in a while. All right, numerator is negative, denominator is still positive, quotient is negative. Oh, and just so you know, with the answer key, whenever they give intervals that increase or decrease, you know, sometimes they include that endpoint. On the AP exam, sometimes they do, sometimes they don't. Don't let that bother you. You know, so if they're saying, where is it increasing? Where is it increasing? What did they say? From, that's so funny. Oh, it's not even defined at 1. That's why they definitely couldn't include the 1. See, this function, that's not in the domain. So they had to break it up at 1. You couldn't just go from 0 to infinity this time. Because it's at 1, it's not the derivative of 0. It's that value is not even in the domain. You can't be increasing somewhere where it's not in the domain. So, yeah, it's increasing when the derivative is positive. But as far as if you didn't include the 0, that's fine. Because at 0, the derivative is not positive, it's 0. So either this would be accepted or with the bracket. As far as the endpoints go, if the endpoints were the derivative is 0, you can include it or not. Because that's stationary point, it's not up or down. It's do either way. Other questions? Yeah? No? All right, let's have some more fun. The good news today, we're going to be doing the same thing. We're looking at that first derivative to give us info. So we already know what the sign of the first derivative tells us. But today we're going to take it a little step further. Suppose you made a sign chart. You're having fun. You're doing your homework. And then you find out at some number C, the derivative is negative over here, and then it's positive on the other side. So there's a sign change, right? If the derivative is negative over here, what does it mean the function's doing? It's decreasing. And over here, the derivative is positive, so the function is increasing. So what's got to be happening at C? If the function's decreasing and then increasing, well, what do we call a value like that? What's that? Like it's a relative min. In this case, it's going to have to be a min. There's got to be a relative min at x equals c. You said what is that point? Yeah. So, but it has to be in that order. First of all, you have to read left to right, or this whole thing doesn't work. Okay. You have to. All right. And you don't have to memorize. Okay, negative to positive. There's a min. No, you can just picture. Slope's negative, then it's positive. You got to have a min there, right? What do you think? You couldn't even have that? You had to just sneak it in there? Yeah. So if you have at some value z, the derivative is positive, and then at z it changes to negative, what do we got there? Relative max. You'd have a relative max at that value. X equals z. Well, that was confusing. So we're still, so if they ask you where's a function increasing, decreasing, where's the relative max or min, all of these questions can be answered by the first derivative sign chart. One-stop shopping. That's what I call this. So I gave you, everything to do. This you all had yesterday. I just added 2 more on. What? Don't make fun of my stuff. So, yeah. So not only are you looking whether it's derivative positive or negative, you're looking for the sign change. Because if the first derivative changes sign, you've got a relative extremum, wherever it changes sign. And then you figure out which one. All right, let's do this. No more games. No more games. Okay, get the derivative of that. Make a sign chart. Yep. make a sign chart, tell me where it's increasing, decreasing, and what type of extrema, if any, you got. Max or min. Yes. Extrema have to occur at critical points, but not every critical point can give you an extreme. You were the square rectangle girl, right? Yeah. Remember that. That's good. Thank you. Thank you. Should I pause it while I'm doing this? All right, so looked around the room. Everyone's getting this. It's awesome. So there was only one critical value in A. It was x equals a 4. They got the derivative, set equal to 0. Made a little sign chart. And the derivative changes sign from negative to positive. So what is that, a max or a min? Min. So we have a relative min at x equals 1/4. The function's decreasing from negative infinity to 1/4, and it's increasing from 1/4 to positive infinity. Good? You got that, right? Yeah. So go on and do B then. Stop sitting there. Right up. All right, I'm going to pause it again. Wait, no. Hit record. I want you to see B. Work on that. All right. These kids are getting B. So in B, was there a max or a min, or what's going on in B? What'd you get? A max and a min. Crazy. Yep. So we had critical values at 0 and 2. So the max is at 0 at x equals 0, and the min is at x equals 2. Any questions on that one? No, it's decreasing from 0 to 2, and it's increasing negative infinity to 0, and then from 2 to infinity. Any questions? No? All right, then go do C. Okay, example C. We worked on that one a little while. You can pause at home. All right, they're ready. So in example C, now I have my sign chart all done. See if your sign chart, you should have two critical values, 0 and 1. And this time the derivative, if I write it out, our derivative is 12x times x minus 1 squared. Uh-oh, what's that square telling you? It's a bouncer. It's not changing sign at 1, and indeed it does not. So see if you got the right sign chart. And then you guys, I didn't fill in the info yet, so you guys got to tell me. What do we got, a max or a min here? We got a min, right? At x equals 0. So we have a min at x equals 0. If somebody said to me, hey, what is the min? I don't know, I know where it is. I want to know what it is. What is the minimum value? What would you have to do? Well, you'd have to plug the 0 in to get the y coordinate. Yeah. Oh, it happened to be 0, too. All right, bad example. But it wouldn't have, it's the y coordinate. All right, so the min is there. And then as far as it's decreasing from negative infinity to 0, I didn't leave myself much room. And then it's increasing 0 to 1, and then 1 to infinity. Now at 1, the derivative was 0. So if you just want to fly all the way from 0 to infinity, that'd be fine too. Let's do this little, are there any questions on that? Good? It's fun, right? I told you it would be. Oh, see, that's the one I should have kept. Hold on. All right, so if the derivative is positive, what do we know about the function? If the derivative is positive, the function is, what'd you say again? Increasing. I gotta get that. If the derivative is negative, the function is What did I do? What did I do?
You spelled negative wrong.
Oops. I was naive. Yeah.
I was like, my God.
Julian's making fun of the way I spelled negative. My T didn't come out. That really hurt my feelings. Okay. So now we lost the whole, the whole momentum here. Yeah. My kids don't remember anything but sparse left out the T. All right. What if the derivative changes from positive to negative? What about the function? Relative max. And if the derivative changes sign from negative to positive? Relative min. Any questions? All right, when you guys do the homework tonight, I just want you to pay attention. Yeah, tonight's homework. Like sometimes they're giving you the derivative. Like, don't take the derivative of this. Like in number 1, this is the derivative. And they say, how many critical points does it have? If your derivative is a fraction, what do you do to get the critical points? Yeah, you said the numerator equals 0, and then the denominator equals to 0. Also, the thing that you got to be careful of, when they give you a graph, don't just assume it's the function. Like they say it in words and symbols. They say the graph of the derivative in number 4, graph of the derivative is shown. At what values of x does the function have a relative max? Not where this has a max. So you're looking at a graph of the derivative. When does a function have a max? When the derivative goes from positive to negative. Not where it bounces. It has to change sign from positive to negative. Yeah. Okay? So when you're looking at graphs, always be careful. What am I looking at? Read it. Did anyone else that started the homework have a question? No? If you don't want to like do 1 or 2 on the back, but then if you're going to knock out a couple, then don't knock out the easy ones. Challenge yourself.
Don't be that guy.
Don't be that guy. The guy that only works with polynomials. If you're having trouble with the fraction type, do the fraction type. Phase shift the ears. I guess that's good enough for today, right? Good job.